I'm here in the cave with a model of the Mars Curiosity Rover. This is a model that was sent to us directly by JPL, so it's a very high resolution 3D model, pretty much directly made from the engineering diagrams. The reason we have this in the first place is that one of our cave's faculty, Dawn Sumner, is one of the members of the NASA Mars Rover science team. And she was interviewed here in the cave about a week ago for a UC commercial, it doesn't really matter. And so she was interviewed talking about her work on Mars, why she got into it, talking about the Mars rover, how she was part of the team that decided initially where it was going to go and so forth. And so that's why we got this beautiful model from JPL. We also have this nice backdrop, which is an actual photo of the location where the rover currently is, taken by the rover. So we are seeing here back in the background there, that is Mount Sharp. The rover is in Gale crater. And actually, the way I positioned it here, the rover is at 1:1 scale. Obviously, it's standing right next to me. It's pretty much where it is right now. And so I just want to use the opportunity, well, it's the name of another rover, to talk about a little bit about this particular model because it's neat. So the most important thing, of course, is that it's really at 1:1 scale, meaning it's actually this tall. This is the main mast, which goes up to about, probably about 7 feet taller than I am. I'm standing right next to the bulk of it. It's about the size of a Mini Cooper, they say. Of course, unlike a Mini Cooper, there's 6 wheels, which are independently driven and suspended, and it has actually 4-wheel steering, so it can really turn on dime, literally, and can go across pretty rough terrain. And I just want to point out some of the more interesting, couple of the more interesting achievements on this guy. So the most obvious thing, of course, is the main mast, which has the big mast camera on top. Actually, there's 2 cameras on top, or 2 camera systems, I should say. One of them is the actual mast camera. You can see the lenses right here and here. So these are multiple field of view cameras. And then to the left and right, there are the navigation cameras, which are stereo cameras that the rover drivers use to plan ahead where the rover is going to go, just by reconstructing a 3D, very, very high resolution model of the environment where the rover is. And then on top of that, I can't really see it very well from where I'm standing, is the chemistry camera, which is essentially a laser that can vaporize rock in the distance, and then it has a spectrometer next to it that can identify the chemical composition of rocks from a distance without touching them, just by zapping them with a laser. And further down here on the mast, we have these things sticking out. That's a package of meteorological instruments just to learn more about the Martian environment and the Martian atmosphere. And then here in the front, of course, we have the articulated arm, which is more than 2 meters long and fully unfolded. Currently, it's folded in this particular model, and then on the end of the arm, right here, there's another component of camera. There's a hand camera there that can take very up-close microscopic pictures. There's also the drill that can actually drill into rock and scoop samples and put them into the sample receptor, which is, I think, right about here. And then they can use X-ray diffraction methods to find the crystal structure of those samples that get put in there to learn more about them than learning about their composition, which you can do with the laser. So the other thing I want to point out is all the way in the back there. So now I'm going to actually pick the rover up and turn it around. Now, of course, this you can't really do with the real thing. It's really heavy, but because we in virtual reality, you can just pick this guy up. Let's see, I'm going to flip it over this way. And you know, I'm going to make it a little bit smaller so it's easier to explain. So back here, flip it a little bit. This here, that's the high gain antenna. The rover can use that to talk directly to Earth. But the thing is that it's not a very powerful antenna, so the bandwidth of talking directly to Earth is very limited. So on the other side here, we have an ultra-high frequency antenna, which cannot directly talk to Earth, but it can talk to the satellites that are orbiting Mars, and then they will relay the signal to Earth. And because the satellites have a much more powerful radio array, we get actually much higher bandwidth from the rover if you go through the satellite relay. And then this cylinder with these heat dissipating fins back here, that's the rover's power source. It's a radioisotope thermoelectric generator, so there's a chunk of radioisotope in there, I think plutonium-238. And it's not a fission reactor, it's just that due to the radioactive decay of the isotope, it generates heat. And then that heat gets transferred to electricity, and that will power the rover for a very long time. It's actually quite the beefy power source. At the beginning of the mission right now, it generates, they say, up to around 125 watts or so. The lifetime of the power source is 14 years, but because the radioactive decay will decay over time, in the end they say the power source is only going to generate about 100 or so watts. But still, at the moment, it's definitely more than enough power to power this pretty big thing. There's one other instrument I want to point out, and that's here at the bottom. I can flip this guy over. This here, zoom in a little bit. That's an interesting little thing. That's the landing camera. It's the Mardi camera. And the first images that came back from the rover were actually taken by this landing camera. That is the descent video, where someone took all the pictures that were captured by this camera, which were at a fairly low frame rate but really high resolution, and then used an alignment and denoising and dejibbering algorithm and also time interpolation to create a very nice and smooth, high-resolution video of the landing, all the way from losing the heat shield to touchdown. It's on YouTube. You should really watch that if you haven't seen it yet. Very cool video. So that's the Mardi camera. And then one other thing that the last thing I want to point out, and that is what I thought was quite nifty, is the wheels here. They have this very funny tread. They have this normal kind of zigzagging tread pattern just to get more grip on the surface, but then the question is, why do they have these holes in here? You can see there are these holes in the wheels. And as it turns out, those are meant to leave a pattern on the track of the rover, which can then be observed by the camera, so that the cameras can be used to judge how far the rover has been going just by looking at these very distinct marks. And then the joke or the gag about it is that actually these particular holes in the wheels, they spell out Jet Propulsion Laboratory, JPL, in Moscow. So they were essentially the JPL guys are leaving their signature on Mars. Okay, that's all I want to say about this. It's definitely a very nifty instrument, and I hope it's going to do a lot of great science while it's up there on Mars. Oh, by the way, now I can see it. So here we have the two main mass cameras. Here we have the stereo arrays, the navigation camera that is zooming a little bit actually. Okay, so here we have the main mass cameras. Here we have two pairs of stereo cameras, here and here. And then this here is the laser that can zap rock up to about 25 feet away. It's the infrared laser. And then also the telescope that can observe the vapor in order to do spectroscopic analysis. All right, so much for that.